Hey guys, how's it going? So one of our subscribers, Brian, you pointed out that we hadn't finished the 2017 paper. Okay, so it's a good thing that you pointed it out, and now we're obviously finishing the paper. If you realize that there are some mistakes, sometimes we make mistakes here. If you realize any mistake, you can just put it in the comment section, and then we'll definitely come around and correct that. Okay, if you realize that we didn't finish some paper, also do the same. Just put in a comment, and then we'll pick up on that, and then do what's necessary. So we're going to answer question 16. We're going to start from question 16. It says evaluate, and then you have this stuff in brackets, and this is supposed to be divided by sign. Okay, so this is divided by sign, and then you have a multiplication sign here. The system that you use, it's BOMDAS. Okay, so even BODMAS, it's still the same thing. So some people would use BODMAS. It's still the same thing. The only difference here is that division comes first before multiplication, but then there's no difference. Okay, you still get the same answer. So this one, it means you do bracket operation first, so we have to remove whatever is in the brackets, and then you do orders. Orders are simply powers. Okay, so question part A, we're going to simplify what's in the brackets first. So what's in the brackets, here you have fractions, mixed fractions. Usually it's easier to deal with improper fractions when dividing or multiplying numbers. Okay, so whenever you're dividing or multiplying numbers, especially, then you can use improper fractions. Unless you're adding or subtracting, there's a way that you can use mixed fractions, but then for this part you actually have to use improper fractions. So 1 and 1 over 5, 1 by 5 you get 5, then plus 1, then you get 6, so this becomes 6 over 5. Then divided by, you just write it as it is. Okay, so here you get 15, 3 by 5 you get 15, then plus 1 you get 16, so 16 by 16 over 5, like this. Okay, then you just repeat this part. We haven't come to it later yet. Okay, so here if you want to get rid of the division sign, you actually have to put multiplication sign, then you invert this one, the number to the right, so it actually becomes 5 over 16 here, then multiply by 2 and 2/3. At this point you can actually change this as to an improper fraction as well, so this one becomes 8 over 3. Okay, you could have done it at this step also, it would have been fine, but then I wasn't using this number, so I didn't bother. So here you can cancel 5 into 5 into 5 like this, and then here 2 is common between 6 and 16, so you can actually get 3 here, then you get 8 here. Okay, so now you have 3 over 8 times 8 over 3. So again, 8 cancels 8 and 3 cancels 3. So you actually get 1. So your answer would be just 1. Okay. So that's it for this question. Let's see if we can do the second question. So second question says these are sets. Okay, sets are simply irrational numbers expressed in the form a square root of b, where a and b are integers. Okay, so this form here, they're called sets. And then you're asked to simplify. If you're asked to simplify normally, that means that these numbers are actually simplifiable. So the way that I do it is here, square root of 75 actually has some factor that you can pull out from there. But then how do you know that factor? You have to use the T diagram. Okay, so the same diagram that you use to express numbers in terms of the products of the prime numbers. That's the diagram that you want to use. So you have 75 here. You just want to know how 75 breaks down in terms of the prime numbers. Okay, so you can even start by 5. We can even start by 3. But 5, it's good. Okay, so because it kind of hammers on this number very fast. So you actually get 5 into this one, you actually get 1, and when the 2, then 5 into 25, you actually get 5 here. So you can repeat 5 again, then you get 3 here, then you repeat 3, you put 3, then you get 1, like this. Okay, so 75 is actually 5 by 5 by 3. You see how this is relevant. Okay, so I'm going to do the same thing for 48. I'm only doing this for the numbers that are inside the square root sign. Okay, so here since this one ends in 8, so it means 2 must be a factor. So 2 here, then you get 24. Again, it ends in an even number, so 2 must be a factor. So you get 12, again, even number, 2 must be a factor. Then you get 6, 2 must be a factor. Then you get 3, then 3 must be a factor, then you get 1. Okay, so here what I'm going to do is I'm going to express these numbers in terms of the products of their prime numbers. Okay, so I'm going to replace 75 here by 5 squared by 3, so 3 times 5 squared. You understand why this is relevant. Okay, so plus this one, it's 3, then square root of, I'm going to do the same thing again, 3 by 5 squared. This is simply 75. So I'm not changing anything there. Okay, so I'm not breaking any laws. So here it will be 2 squared. I can say 2 squared by 2 squared by 3. Okay, so I'm pairing up the prime numbers here. Okay, I'm pairing them up, and here you are allowed to actually split this into 2 square root signs. So this one would be square root of 3 multiplied by square root of 5 squared, like this. Okay, so this one will also the same thing, square root of 3 multiplied by square root of 5 squared. So you're allowed to do this according to the laws that govern sets, okay, or that govern maths. So this one would be square root of 2 squared again, then square root of 3, like this. So here a square root of 5 squared, square root and square, they actually cancel, so you actually get 2 by 5 square root of 3 here. Then here you actually get again 3 by 5 square root of 3 here. Okay, then here you actually get minus this here gives you 2, so the square is cancelling with the square root, and then you actually have another 2 here, then you have a square root of 3, like this. Okay, so here you actually get 10 square root of 3 plus, then this one is 15 square root of 3 minus 4 square root of 3. So this simply means you have 10 square roots of 3, you have 15 square roots of 3 adding, so obviously you get 25 square roots of 3, then you're subtracting 4 square roots of 3, then you get 21 square roots of 3. Okay, so the way that you can do it is to just factor out square root of 3 here, then you're left with 10 plus 15 minus 4, so you get 21, so you get 21 square root of 3, like this. Okay, so this is how you work out these sets. And obviously you're done, and you can move to the next part. Let's see what the next question says. The next question, it says you have a solid cone. Okay, it is this base radius of this much and a perpendicular height of this much. Okay, so you're asked to find the slant height. So with these questions, you should be able to actually draw whatever shape or whatever solid that they are giving you in the context. Okay, so here would be like this, like this. Okay, so this one would be there, and then you have the radius here. So the radius here would be I actually given it as 7 centimeters here, and then the height you're given it as 24, so this one would be 24 here. Okay, so what you realize now is that the height and this one, they actually meet at a right angle, just like this. Okay, so what you want is this slant edge here. This slant edge here, you can even see it from here that this one is the hypotenuse of this side and this side. Okay, so the slant edge, you can even say let the slant height, so you can say slant, forgive my handwriting. Okay, so slant height BH, like this. Okay, so by Pythagoras theorem, by Pythagoras theorem, h squared equal to 24 squared plus 7 squared, like this. Okay, so h squared equal to 24 squared, just do it on a separate piece of paper. So you actually get 8 here, actually get 4 here, then you have 16, so 16, so you put the remainder, then you carry the number of sets, then you have 8 plus 1, then you get 9 here, then you simply add, so you get 6 here, then 17, so 7, then you carry the 1 here, then you get 576. Okay, so this is 576, then 576 plus 49, again you go 576 plus 49, then you get 15, so 5k1, then you get so you get 5 plus then you get 12. So 5 plus 7, then you get 12, so 2k1, then you get 6, so you get 625 here. So whenever you have numbers like these ones, they're sort of like, a great way of validating whatever working you're doing. I'm in paper 1, so I don't have any calculator. If I'm getting a number like 313 here and then I have to type in the square root, obviously I'm doing something wrong, okay? But then if I get a number like 625, it's a perfect square, so obviously it makes sense, okay? So I can actually take the square root at this point here. So square root of 625 is what? Oh, it's actually 25. So 25 what? 25 centimeters. And this was a beautiful set of questions. So, and then it was really productive, okay? So I'm really glad that Brian came through and then just told us that we had to finish this paper. So thanks so much for watching. Make sure you like, share, and subscribe. In next video, a follow-up video will come, and then we'll continue with the other questions, okay? So Yuba, out.